Alright, so let's have a look at another electromagnetism question. Here we're told to find the terminal velocity of a particle when accelerated from rest through a potential difference of 1000 volts. We are given 3 particles. We're asked to do this for an electron, then for a proton, then for an alpha particle. Okay, so we'll do the electron we'll set up our general framework for this first. So in the case where we're after the terminal velocity of a particle when accelerated from rest through a potential difference of a certain voltage, we know the work done will be the kinetic energy gained. So work will be change in kinetic energy. We know that work is the charge times the potential difference. This is Q times V. And we know the change in kinetic energy is just the final kinetic energy, which is 1/2 times the mass times the terminal velocity squared. So all we're after in these questions is terminal velocity, so we're going to rearrange this straight away. Multiply both sides by 2, this gives us 2 QV is equal to mass times terminal velocity squared. So this was multiplying both sides by 2. Divide both sides by the mass. This gives me terminal velocity squared is 2 times the charge times the potential difference over the mass. This tells me that terminal velocity is the square root of 2 times charge times potential difference over mass. So we need to use this formula 3 times, once for the electron, once for the proton, once for the alpha particle. Now for this question we need to identify what the charge and mass of electrons and protons are. So when we do this, we actually need to know this information beforehand. So we'll start with the electron. So the mass of an electron is about 9 times 10 to the minus 31. 9 times 10 to the minus 31 kilograms. The charge of an electron, Q, is equal to minus 1.6 times 10 to the minus 19 coulombs. Now when we plug this into our velocity formula, we're going to make it positive. We'll leave the voltage positive, the charge positive, the mass positive in order to actually calculate a terminal velocity here. So we'll do the electron first. So the terminal velocity for the electron is equal to the square root of 2 times 1.6 times 10 to the minus 19 multiplied by 1000 divided by the mass, which is 9 times 10 to the minus 31. So therefore the velocity terminal for the electron, put this all into our calculator, square root 2 times 1.6 times 10 to the minus 19 times 1000 divided by 9 times 10 to the power of minus 31. This gives me I'll take them all to 3 significant figures. If you're told a different measurement, obviously do that. 1.8856 ... times 10 to the 7. So this gives us, therefore the velocity terminal for the electron is 1.89 times 10 to the 7. Now let me just confirm I have this number right. We have 2 times 1.6 times 10 to the minus 19 times 1000. Yep. So 1.89 times 10 to the 7, and this is in meters per second. So this is the terminal velocity. This is quite fast, right? This is quite a high velocity. It's not quite as high as, say, getting close to light speed. It's not a times 10 to the 8 order. It's one order below that, but still fairly fast. With these equations, you want to be very careful with evaluating these. If you're doing them on a calculator, anything that starts to become larger than the calculator screen, be very careful. Right, so you want to check these very carefully. So we've done the electron. Now we need to do the proton. So the mass of a proton, so we have proton mass in kilograms is going to be 1.67 times 10 to the minus 27. So mass of a proton is 1.67 times 10 to the minus 27 kilograms. And the charge of a proton, well, the charge of an electron was -1. Charge of a proton is +1. So charge here is the same as the electron. It's 1.6 times 10 to the minus 19 coulombs. So we're going to do the same process all over again. We have the velocity terminal for a proton is the square root of 2 times the magnitude of the charge, 1.6 times 10 to the minus 19, multiplied by the potential difference, 1000, divided by the mass, which is now 1.67 times 10 to the minus 27. So this tells us that velocity terminal for the proton is, so we have to evaluate this whole thing again. We are going to get 1.67 times 10 to the minus 27, 4.37740, and let me just check this is all in the calculator correctly. Yep, 4.37740 ... So therefore, the velocity terminal for the proton is about 4.38 times 10 to the 5, this is times 10 to the 5, meters per second. And this is the answer for B. As was the case for both of these are both 3 sig figs. So 3 sig figs each time. If you're told to round a different way, round a different way. If you're not told to round, a long string answer is usually fine. It doesn't really matter. If you have an answer that's rounded a particular way, it's trivial to change the rounding. So what matters is that you're actually getting the values here. Now part C, this is the harder one, alpha particle. Often students don't really deal with alpha particles. So it's not an overly common thing to have to know the mass of or the charge of. So we can actually look up the mass of an alpha particle. We could calculate it, but we'll just look it up. Mass of alpha particle. So this is going to be 6.64 times 10 to the minus 27. So the mass of the alpha is 6.64 times 10 to the minus 27. And this makes sense because this is about 4 times the mass of a proton. Now an alpha particle is in fact a helium-4 nucleus. So it has 2 protons, 2 neutrons. The protons and neutrons roughly similar mass. So 6.64 is about what we would expect in kilograms. And the charge associated with an alpha particle is +2 because it has 2 protons. So the charge is going to be double the charge of a proton. So the charge here, Q, will be about 3.2 times 10 to the minus 19 coulombs. So the terminal velocity of an alpha particle will be the square root of 2 times 3.2 times 10 to the minus 19 multiplied by 1000 divided by the mass, which is 6.64 times 10 to the minus 27. So terminal velocity of the alpha. And again, we've got to be very careful every time we do these. Put all the numbers in. The calculator only shows so many inputs on your screen. Usually when you do these questions, they're with a calculator. You can do them with, you can say, for example, program them with Python, but it's a slight overkill to use something like Python to do something so trivial. So you put that in, just monitor the inputs very carefully. So we get, let me check these are right. Okay, 3.10460 ... times 10 to the 5. So therefore, the terminal velocity of an alpha particle once passed through this potential difference is about 3.10 times 10 to the 5 meters per second. And this answer, again, this is to 3 significant figures. So this is how we calculate the terminal velocities of the following particles when accelerated from rest through a potential difference.